All right, so now we can do an evasion attack on images on the MNIST dataset, and I found this one very helpful because it's easy to see what's going on. So this is using those handwritten numbers that we're going to sort into categories to identify the digits. So let me make a new notebook. All right. And so that will put in the SecML library and get ready, and then it will load the MNIST data set. And what we're going to do is choose only a small set of samples, including only the digits 5 and 9, to make a simple situation to study here. All right, that one is still going. So it's going to take 100 training set samples and 500 validation and test net samples. This is the database that has many thousands of data sets, but we're choosing just some of them to get a smaller set to work with. And here's what they look like. All right, there are 5s and 9s, and here's the, I think that is the label, not a prediction. Yeah, it's just showing, so you can see there are 5s and 9s, and they come with labels, so we know whether they really are 5s or 9s. So now we'll train a classifier using a support vector machine and see how accurate it is. To tell the 5s from the 9s, and it's 93% accurate. All right, so here's an evasion attack. And now up here we defined a classifier called CLF, and down here we're going to use this SecML attack type, attack evasion, and it is going to be fed in that classifier as a parameter. So once again, this is an academically designed attack where if you have complete information about the machine learning model you're attacking, you can then carefully plan an attack that will be most effective at confusing it. So we're going to create a small group of attack images, 25 images. We're going to make 25 images that this thing will misclassify. So here it is predicting what changes in an image would make it most confusing to the model. And the attack is complete, and you see the accuracy on the test set. Before the attack was 100%, but after the attack it's down to 12%. So the attack is very effective at confusing the model, and we can see what the modifications were to have that effect. And here they are. This is the original 9. This is the modified 9. And you see these little ghostly images make it misclassify as a 5. Here's a 5. And those little ghostly images make them think it's a 9. This one's a little more surprising. But you see, anyway, you can see a little bit of noise was added. A little bit of alteration was enough. These sort of shadows are enough to confuse the model and make all these ones classified incorrectly. And so there are some, you can do some modified versions of this to find some flags. But I found this very helpful. Now it's very easy to understand what these evasion attacks are doing. And so if you had some images you wanted to, you could now imagine various social engineering versions of this. Like there are people who take handwritten numbers and turn them into digits and use them for things like bank account numbers and amounts on checks. And you could carefully make amounts that look like one number to a human, but they look like a different number to a computer scanning it. So you can see how this is an important type of attack that could be used to commit various forms of crime. So I'm going to stop this recording.